Good morning, good afternoon, and good evening, everybody, depending on where you're connecting from. Welcome to yet another Citrix Ready technical webinar in our Citrix Ready technical webinar series, where we showcase how Citrix and our partners, like Acceptor today, have integrated to deliver valuable products and solutions to common problems faced by our customers. I'm Anil Kumar, your host today, and I'm part of the Citrix Ready technical marketing team, managing the network ecosystem of products. And before we get started, I kind of wanted to provide a very brief introduction of what is Citrix Ready and what we do here. Citrix Ready is an end-to-end technology partner program that showcases and recommends third-party products, solutions, and services that demonstrate compatibility with Citrix. So with this, customers can quickly and easily find solutions which are trusted and recommended by Citrix. And you can find all these products in Citrix Ready Marketplace hosted at the below links. So please visit our website, and if you'd like to know more about Citrix Ready program, if you're a vendor and want to validate your products with Citrix, please visit citrix.com partner programs /Citrix Ready, and you should have all the information over there. You could also drop us an email at citrixready@citrix.com, and we'll get back to you with all the information you require. First, if you could move to the second slide, please. So we have Acceptor with us here today, and to present about Acceptor, we have our main speakers, Foster Oliveira and Dr. Stephen Albrecht. I'm really proud to have them on this webinar. Hi, Foster. Dr. Stephen, could you provide a brief introduction about yourself, please?
Hello, good afternoon. My name is Foster Oliveira. I'm the Principal Security Architect for Acceptor, and I'm sorry I'm having a bit of problem with my PowerPoint. I work with Stefan and the rest of my colleagues in multi-factor authentication, supported by cognitive authentication.
And hello, my name is Stefan, and I'm the Principal Research Scientist at Acceptor. So I'm responsible for machine learning and artificial intelligence with respect to multi-factor authentication at Acceptor.
So I'm going to talk about a brief overview of the challenges that we've got on identity and access management. So access to enterprise resources nowadays is done over all kinds of devices. We've got IoT devices, we've got wearables, mobile phones, desktops. It never ends. And at the same time, users nowadays, they expect to have a turnkey solution. They expect to arrive at the enterprise and be able to use the enterprise resources without having to go through multiple steps. On the other end, credential compromise is and it continues to be a key exploit. It's considerably cheaper nowadays to attack passwords by brute force. There is a huge market of CPUs and GPUs available, and that creates an easy to compromise a password. On the other end, 81% of the attacks we are seeing in the market are using either stolen or weak passwords. So passwords are a problem. At the same time, the boundaries in the enterprise have vanished. You no longer have an inside and outside perimeter. You have private cloud, you've got public cloud, you've got on-prem servers, and they're all talking with each other. That, combined with the abundance of containers, VMs, all kinds of serverless technologies, creates great challenges to keep data protected. One compromised credential nowadays can yield access to multiple resources. Users are encouraged by policy to reuse passwords both on their work and personal related websites and corporate resources. Passwords continue to be a burden on help desks. It is a a cost of $23 per user to reset a password, even with self-reset facilities. On the other hand, increasing complexity or rotating the password more often is not the solution. It encourages reuse of the password. And in fact, it's part of the problem that we are facing nowadays. As I said previously, cloud and container offerings are shifting the boundaries of authentication and data protection. And where Accepto and Citrix get better together is we believe that constraining the user and requiring multiple logon mechanisms encourage unsafe behavior. If you ask your user to type his PIN 20 times an hour, someone is going to shoulder surf that PIN. Friction is a major barrier to the adoption of multi-factor authentication solutions, and in fact to any kind of security solution. And we believe that the answer to this challenge is to have cognitive authentication combined with multi-factor authentication. So in this case, what you see here on the screen is a typical Accepto and Citrix ecosystem. On the left-hand side, you got your extranet users and internet users. On your right-hand side, you got the Accepto eGuardian API, which we'll talk about in more detail in a moment. We got the Radius server, an Active Directory, and in the middle, joining all of these pieces together, we've got the NetScaler gateway that is used to protect the corporate resources. So in this case, I've got a four-step diagram showing how easy it is to set up the solution. So you set up a non-privileged user in Active Directory, which we are going to use for LDAP search. You configure Radius to authenticate to Active Directory. You add a post-authentication step to the Radius configuration that allows it to use our solution. And finally, you change your Citrix NetScaler unified gateway to use Radius for authentication. So in this case, I'm showing you a small video I took of how to configure Radius. I'm now editing the RadiusD config file, where I'm going to check if the policy and virtual servers are enabled. I know it's a bit like watching paint dry. Once that's done, I'm going to edit the LDAP configuration of Radius, and once I get the right file, right. In this case, I've got a pre-configured AD server, right where I've got my cursor. That's the server that we are going to use to search for the users and authenticate the users. We now need to provide an identity, and I've highlighted the password because this is the typical scenario where, unfortunately, we can't totally get rid of the password. And then we have a base DN, which is where we are going to search for our users. And finally, we've got a filter, which we can tweak to search for certain properties. And now I edit the authorize module. And I'm going to configure LDAP. In this case, I'm using the distinguished name CN users, DC example, DCnet, but obviously you can customize it for your environment. And finally, to configure the Perl module, which we are going to use as the connector to the eGuardian API. It's as simple as renaming the script that you are going to call. Once that's done, you edit the Perl script that Accepto provides to its customers. And in that Perl script, you're going to configure which attribute you're going to use to identify the user, a UID, and a secret. You can obtain these details from your Acceptor account once you subscribe to our service. One last note, you'll notice that there is a URL that is composed as part of the authentication. You may want to configure your firewall, IPS, or WAF to allow this URL through and to allow the Citrix to connect to our website. Finally, you configure the client range. In this case, I'm going to use the Citrix Virtual Gateway subnet. You'll notice that there are quite a few pre-configured secrets that come with the default configuration. You may want to delete them after you have done a proof of concept, but for this case, I left all the defaults as they are. Once that's done, what remains is to test. And once again, notice that you are going to have to use a password for this test. And unfortunately, Radius is a clear text protocol. So you will want to protect these credentials as well as you can. Right. Next, we've got the Radius configuration itself in the Citrix Gateway. So in this case, I'm typing in just a name, a memorable name. Not very originally, is the demo Radius. I'm going to connect to that Radius. Again, once more, the secret key. Remember, it's a clear text key. And I'm going to change a parameter. This is essential. I'm going to give it more time for the timeout to allow for the Radius to go out, talk with the eGuardian API, and come back. Then I test it. All set and done. You now have a Radius configured. Once you've got the Radius configured, you create a policy. And this is the authentication policy that you're going to apply to protect your gateway. In this case, I've chosen to use a very simple configuration. I'm sure you will have use cases where more complex web policies are required. Once you've got the policy and the Radius configured, you can create a new gateway, which is what I'm doing, or reconfigure an existing one. There we go, demo certificate. Then we select Radius as our authentication method. We select the newly created Radius server, and we're all set and done from a Citrix Unified Gateway point of view. What I'm about to show now is actually what happens after we configure the web gateway. So we've got the Radius, we've got Active Directory, we got the Citrix, and now we are looking at how a user will perceive the product. At the right side of the screen, you'll see it's a mobile interface. It's our Authenticator product. It's called It's Me. And that's what I'm going to use today to authorize login to the Citrix. Sorry, guys. So what I've shown on the screen was basically how multi-factor authentication can be used to protect access to corporate resources. I hope that I've showed you how simple it is to set up our solution to add an extra layer of security. And I'm going to reiterate what I mentioned earlier on. Having something that the user knows, such as a password, having something that the user owns, such as a token or a mobile, is not enough. I've seen multiple times in the organizations people reusing other person's smart cards. I've seen passwords being shoulder surfed. I've seen cloning being used. And it's clear that we need to have a multi-factor authentication approach, but it needs to be tempered with a measure of intelligence and the use of biometrics. User behavior analytics, it's a big word, but it's crucial. It needs to be used to determine identity. And by determining identity in a strong manner, it's when multi-factor authentication is an effective deterrent against the threat actors and to stop credential exploitation. What we see in the market is that some multi-factor authentication solutions are cumbersome. I mentioned earlier, if the user has to repeat actions 20 times a day, they won't 20 times an hour, sorry, they will stop using the solution, or they'll find creative manners to go around it. On the other end, a lot of the solutions in the market are using a binary approach to access. You're either pass or fail your authorization or your authentication. That is not tempered by any measure of user behavior analytics, and it becomes cumbersome. So using cognitive authentication, it allows us to have a high degree of security. It allows us to reduce user friction. For example, we can allow a user to access a website without authentication if we know that his behavior is positive and safe. And less friction, in the end, encourages users to have a safe behavior and increases the adoption of the solution within the enterprise. Security does not need to be a barrier. How do we do this? We have continuous monitoring and evaluation of the user behavior, and that allows us to have a good picture of the identity. With that picture, we can create a risk score that is associated with each of the users, the applications they use, their behaviors, their diversion behaviors. And we have the ability to quickly audit and alert when something is happening that is out of the standard. Every time the behavior deviates, we can create an audit and an alert. And that allows the enterprise to react quickly and to either stop the attack or to raise the bar. When you combine multi-factor authentication with cognitive authentication, you decrease the number of credentials that the user needs to know. That's a fact. And at the same time, you decrease the cost associated with password resets while increasing security. That's why this is a very powerful combination. Less friction between security and usability. Users not having to have multiple passwords to authenticate will increase your security posture. And as I said, multi-factor authentication on its own is not enough. And it's subject to the same or some of the same issues that passwords have. User behavioral analysis is what adds the extra layer of authentication to this solution, and it fits all the issues I've mentioned in the past, such as shoulder surfing, cloning, or brute force. On the other hand, having a single pane of glass where you can watch what is happening on your enterprise and be alerted for all the security issues is essential. You can't react after the fact. When you combine Citrix traffic security with our authentication, your corporate resources are very protected and you gain greater insights of what is happening on your organization. Now, I've been talking about the Acceptor eGuardian, a bit of detail on these, and then my colleague Stefan Ulbrich will pick up and explain more in detail of what eGuardian is. But in summary, it's our backend. It's where our intelligence happens. It's what allows us to perform forensics, track user behavior, analyze traffic, and interact with other sources of intelligence. We integrate with a variety of sources of intelligence, such as syslog, Splunk, anything that is a database, we can use it for analysis. It also provides you with an auditable trail of user and application behavior and what transactions are taking place. And these are essential to model user behavior. On the other hand, it provides you with risk-based assessment, and that risk-based assessment is used to create or, how can I say, raise or lower the security requirements needed to access a resource. And we treat any resource as a subject for authentication. So we say resources in databases, financial transactions, websites. It can be anything that can be authenticated, we can cope with. That combined with an audit trail that is quite comprehensive, and it can be tailored to alert depending on how critical a resource is and what is the user behavior and associate the transactions, allows you to monitor your enterprise quite effectively. And in the end, the synergy between eGuardian and EatsMe, which is our client authenticator, is what allows us, Accepto, to implement a multi-factor authentication solution.
Right. First, if I could take a quick question before we move on.
Yep.
Right. So you did mention that multi-factor authentication is not enough, and we need to monitor and evaluate user behavior, and you also did mention something about risk-based analysis. Could you give us a real production example which you've seen which has really helped? And when it comes to user behavior monitoring, what exactly are we monitoring from the users?
So I can give you two examples, a positive and a negative example. I have worked with an organization where multi-factor was mandated, and they were using a smart card to authenticate to an application. And due to cost reductions, that smart card was shared amongst various employees. So effectively, it defeated multi-factor authentication. Okay.
Right.
I can give you the positive use case where, by using our authenticator, we have several financial institutions, as an example, using our backend to measure user behavior and use that user behavior to allow them to perform certain financial transactions or not. Okay. Case in point is, for example, if your PC accessing your banking website is in the UK, and suddenly there is an authentication attempt coming from, let's say, China, clearly something has gone wrong, and you are clearly not who you say you are. Does this answer your question?
Right. I think that's very very intuitive and very secure. I mean having to monitoring where the user is logging in and ensuring that his is at the correct place always really helps to kind of reduce those risks.
That is one of the factors we measure. Okay,
Right.
we do measure other attributes. It was just an example.
Right. Sounds great, Foster.
Okay.
I think we can move on with the next slides, please.
Okay, then I'll take over. So again, thank you, Foster. So my name is Stefan Ulbrich again, and I want to give an introduction of the techniques that empowers our cognitive authentication. So the methods that give us the possibility to compute a dynamic level of assurance or risk score about a person. And these techniques are all based on machine learning. So I give a quick introduction / deep dive or overview into the materia. So I'll starting with what machine learning in general is, or which problems it tries to solve, especially in the context of cybersecurity and authentication, cognitive authentication. And in this context, there were two approaches, classical approaches. So one is that you derive policies, like the one Fausto just mentioned, that when you're in China, or the transaction is triggered from China, while you are located in England, that this is a discrepancy. This you can express as a rule created by humans. On the other hand, you want to use machine learning to get several benefits, or a system that can outperform what human can do there. And I'll briefly stop with introduction on the application in the scope of authentication systems. So Fausto, if you may, please, the next slide. Fausto, thank you. Oh.
Yeah, it should be in the next slide.
Okay, it takes a while until it updates here. So machine learning actually and artificial intelligence are terms that are rather old, that have been in the science and in the community around for quite a while. So for instance, the term machine learning has been termed by Arthur Samuels in the late 50s, and also artificial intelligence, well, a term that is more difficult to define, because, well, if we hear the word artificial intelligence, well, I first thought of Star Wars and robots running around. So machine learning itself there's a quite complex definition in there, but actually it describes a system that is able to perform a task, and it progressively improves the more data it looks at. And what's also an important point, you don't need to explicitly program anything. So the system is working actually like a black box. You bring in data, and it solves the task and gets better continuously over time. Artificial intelligence, well, basically that's only the science that deals with creating intelligent machines, whatever that might be. So it's often seen in the scope of reasoning, of solving problems, or decision making. That's actually that case where we use it here in this case. So we see it as a system that is able to make a decision on its own and doesn't need a human intervention. Whether these decisions are made from a human teacher or based on a rule set or created by machine learning is independent of this definition. Of course, artificial intelligence is, the scope is much broader. It can go to motion planning in robotics or in autonomous driving, actually. So machine learning is, well, a lot in the media recently, or basically since last decade, thanks to autonomous driving in big companies as Google. And the reason behind it, why it gained so much in popularity within the last years, or the last decade, is first, that we have a lot of computational power, which we didn't have in the 50s. So our computers are much faster, and with the rise of graphical processors, like from NVIDIA or also Intel's dedicated processors, we have so much computational power at our fingertips and parallelized computation, which we didn't have before, but we also have a lot more data than we used to have. So with big companies collecting every data you could imagine about you, well, Facebook has been quite in the media within the last weeks, as they a little bit collected too much about you, gives us, well, the power. We have a lot of data that we cannot process anymore manually. So the time for machine learning has come within this last decade. So Fausto, if you could please proceed. So which problems can we solve by an artificial intelligence solution? And especially in our context with connective authentication, it is the question for us, if a user tries to attempt a resource, a web page or a server, it's a question whether we need another multi-factor authentication, so another level of friction because we don't really trust him, or whether we give him access right away to the resource. And this decision is made by systems based on knowledge it somehow has collected over the time, or that has been encoded into it, programmed by an expert, or gained from data over time. And for that, it needs additional information about the access attempt. So that's what we always call context. So context is the key about that the machine can make a decision. It has to know something about you. And again, in the example Fausto gave earlier, if you're in China, then China is one attribute. Your location is one point that is important to make a decision whether to grant access or not. And based on this knowledge base and its rules or internal happening in this black box, it computes or spits out a level of assurance or risk to score that it makes or founds a decision on. So for cognitive authentication, we need to acquire data. We need that to decide whether an access is legit or not. We have to capture the context, and we have to use as many or multiple sources as possible. So this might be a device fingerprint. For instance, your browser usually knows where you are and has certain characteristics like which languages you've got, which plugins you've installed, whether JavaScript is enabled or not. It gives a uniqueness to you that is kind of characteristic for you, like a fingerprint in real life. But these can be faked also, of course. So we try to collect as many data as possible. We have a mobile app, so we can also access to the sensors we've got on the phone. So we can get the GPS position and can, for instance, validate whether your mobile phone is in China when the attempt comes from China. When your mobile phone is still in England, maybe something's wrong, and we access to provide another level of assurance, like a fingerprint on the mobile phone. Also, we can use other data sets from the client directly. So usually big companies collect data over the years, and they have a good knowledge about the profiles or data about the clients. And we try to incorporate that to improve our predictions, or probably even bought in third-party data sets. So Fausto, could we please progress? Okay, and the key there is we've got attributes. We collect data quite a lot. So from a browser, we could get geographic data, IP addresses, which ISP are you using, whether you're using a VPN connection or SSH over there, which browser OS. It's a lot of data you can collect over an attempt. And those can be distinguished into categorical data. That means, well, your operating system is either Windows or macOS or maybe even Linux. So these are discrete set of possibilities, but they could also be continuous. Like time is something that is continuous, of course. So you can build up a relation, and then there's an infinitive number of possibilities in between two time steps. Also, we can use data from as I told, should collect as much as possible and be able to progress them. So from mobile devices, we can get Wi-Fi connections or whether Bluetooth devices are close to it. We can also access to biometrics or the habits of the user. When we now have this data and we want to create a policy that decides anything, it has to work on these attributes. So for instance, we have got the attribute China, but we have got the attribute the mobile phone is in England. And from that, we have to create a rule. And the best is if we combine attributes and as many as possible into very complex rules, because they will be very difficult to reproduce by an attacker can very difficult fake the personality or the profile of a person, the more attributes were taken into account. So let's take an example for a very simple rule. Basically, that's the one I just said. So we could define a rule for deciding whether we want to trigger a multi-factor authentication or not. So if we say that the position of the mobile device and the position of the web browser should be less than a mile, otherwise we'll trigger the or increase the level of friction because our reliability, our level of assurance decreased, our level of trust in the user. So next slide, please. Okay, here it is. So I'm going a little bit more into the details and the internals of our eGuardian. So eGuardian is a policy-based artificial intelligence system. So our policies may be defined by a human expert. So that means the rule you've seen before, like that your mobile phone has to be close to your browser, something we can specify in our system manually. That means actually these rules, we have got a human expert. You can read the rule either graphically or in a special language created to define those rules. You can read it, you can understand it. These rules are obvious for the human. We don't need a lot of data sets. It's common sense what we want to implement in there. So we give our system common sense for the human. And this provides a very basic and secure, highly reliable level of security. Problem is, of course, you need knowledge about what you're doing. It's called domain knowledge. You have to know the world you're operating in. You have to know how an attacker thinks, for instance. And that means it is not adaptive. You define a rule and it will never change unless you change it. Also, you could make mistakes by creating a manually. So they are rather hard to maintain and also rather expensive because you need a human to do it. Bottom line, we have very high confidence in rules created by human, but they're very narrow. You cannot possibly cover all aspects of, let's say, 100 or 200 attributes. You cannot put them in relation by hand. But what you do, you can really trust in. So next slide. The alternative to that is machine learning. Machine learning this is a program or a part of our system that looks at data we previously collected. And the nature of this algorithm, we'll go a little bit into detail in 2 slides, is they detect unknown relations. They are adaptive. With the more data that come in, they detect how the things work, how an attribute like location depends on time, for instance. So in the morning, you're usually close to your bed because you just got up, just as an example. And they're working automatically. Computational power got rather cheap nowadays, so the costs are tremendously reduced using machine learning. Well, on the other side, it's less explicable. You cannot really understand what the machine learned because it's some sort of hidden in mathematical formulas. And what's even more important, you need a lot of data to be able to build your models. So you need huge data sets. So the system has to run perhaps for a couple of months before it really gets a valuable contribution. In the end, we have less confidence, but it's wider. We can introduce more security in there, but maybe we cannot really confide completely into it. So our solution, what we do in eGuardian, is we have a mixture of expert. So that means we have multiple machines learning, the human, so human-based policies, but also machine learning, and their decisions are weighted up, and we make a final decision based on, well, like in the democracy, on a democratic vote, we make our decision at the end. Next slide, please. So I think we're running already a little short of time, so I'll hurry up a little if the slides update. So I've got an example with how I wanted to show that human-based policies, as good as they are, give a problem. In this image, you can see we have a user request. So we first compare the mobile browser location with the mobile phone and the browser location. If it's far away, well, check the dates. Is it possible that the last login of the phone, well, it was 2 days ago? Yeah, in 2 days you can travel a lot. So if you pass this test, where that's plausible, or your devices were close, you check whether the language settings have changed of the browser. If they've changed, no, I don't grant access, because who changes the language setting of your browser? If you go to China, well, I certainly wouldn't change my language to Chinese there. But if my device would have been stolen, probably a local would change it. Then we continue with checking the browser version, and so on and so on. And even if we start combining attributes, these rules get more complicated and complex. So back to the human rules. They are human readable. You could see it on the right side. You can create them with a graphical editor. You don't need programming for that. You can just create a graph like you've seen on the right side. Or you could write it in a domain-specific language, or if performance is the most thing you care about, you could write directly in a programming language. You could even do it directly in SQL and create a database looking for examples where you accepted a request in the past, for instance. But the more attributes we get, the more complex this graph gets, and the combination. So if you say you have 3 attributes, and each attribute can have 3 values, then the combinations, it's 27 combinations. So it grows exponentially very, very fast. And this holds especially if you have numeric values. Time, the number of logins per month, for instance. So in the example of the right, where do you do the threshold of being too far away? These are things that are quite complicated for humans to do. However, combined attributes are the key to the increased security. That's why we go to machine learning. On the next slide, please. So here you see on the right, it's a mock-up where you can see how the result of a machine learning looks like, what the machine thinks. And yeah, basically they are thinking in mathematical equations. So you can see here we have a set of fraudulent attempts, which are pointed red, and a set of good attempts pointed in blue. And you have got 3 attributes. And this blue curve separates them in this mathematical world. Let this be an example for a perfect classifier, whether something is bad or going on or something is really fine. No human can really deduce a policy in a written form from that one. So the knowledge is implicitly stored in these things. Good things to make it fast. Typically, we don't need any domain knowledge. We can work very well with a lot of number of dimensions. So all the aspects we can get from a browser fingerprint, we can use. We can use all the data you collect from your phone, no problem. So the higher the dimensionality, of course, this imposes problems as well, but it will outperform any human. And we can also define nonlinear relationships. So the really complex things in there. Again, bad thing, in order to get those models, we need a lot of data. But we can mostly adapt over the time. So if the attackers get new trends or new ways of attacking your system, the system will slowly, but it will adapt to it. So it will keep up with them in the best case. A word on the methods we use there. They usually come from a field in mathematics called anomaly detection. So you can use it in medical data or in network analysis or in authentication, like in our case. And they also classified as unsupervised learning. That means when you get a request in your data set, nobody told whether there was an attacker or not. You cannot really know that. So you don't have this data, but the algorithm is still capable of detecting in your old data, which nobody had the time to look what was good or bad. This algorithm can find it. Typical examples are support vector machines, neural networks, or clustering algorithms in general. Next slide, please. As kind of a bottom line slide, summing up slide. So machine learning can combine many different sources. So I talked a lot about device and browser fingerprints, but also you can do biometrics from fingerprints to face recognition easily. Also to movement. You can even connect those algorithms to observation camera. So machine learning is a huge field and covers so many aspects of our lives. You also can, and that's one core aspect that we have in eGuardian, you can create predictive models. So on data that is highly temporal, like the routine of your daily commute route or getting up at your home, then you go to work, then you go to the gym. So regularities that you have every day. If you differ from those, the machine will detect it, that your daily routine is perturbed, and it will ask you, hey, is it still you? Because you behaved rather abnormal today. Please give your fingerprint just to be sure. And when we combine these additional dimensions or attributes, or you want to call them, so if we fuse multiple data sources into the system, we, on the one hand, increase robustness. So we can rely on what we're doing. And also the precision will be very good in the end. And for an attacker, well, that's basically the assumption we have. It is impossible to imitate all aspects of a person, of its behavior. It's something that makes us unique. If an attacker would be able to really imitate me completely fine, he would also be able to trick any human being. So we assume that up to a certain level it's possible, but the more data sources we combine, it will get hard to impossible to break this level of security. So in the end, it leads to a reliable and dynamic level of assurance. So I'm coming to my last slide, please, Fausto. So we were talking a lot about machine learning. So in our opinion, it outperforms the human in many aspects. It can handle unknown data. It can find its own domain knowledge. We don't need an expert. It can handle data sources from everywhere and no matter how many facets this data may have. And it's flexible. It will find out novel trends and attacking your system. And it's much cheaper and easier to maintain. And it's what powers our eGuardian on the bottom. On the other hand, human policies still are the most reliable source of what you can define. They're hard to maintain, but in combination with a machine learning as a mixture of expert, it becomes a really unbeatable system. That's the end of my talk, I guess. So I think the next slide is an invitation for questions that you may have. Thank you very much.
All right. Thanks very much, Dr. Stephen and Foster. I think it was a great presentation, although we had a bit of audio issues at the end. I think we have a few minutes for the questions. Let's take up a few. So the very first question which comes to my mind, I think we have a few IT specialists from various enterprises who are attending today. So if they would like to know how to implement Accepto's eGuardian and the It's Me solution in their environment, how easy is it? Is it Is it a cloud-based solution? Do they have to install anything on their internal servers? Like if they have to set up a POC, how easy is that?
Okay. If you don't mind, I'll fill that question. So the simplest way to set up a POC right now is to go to our website, www.accepto.com, and subscribe yourself to our free service. Download our mobile app and follow the instructions on the website. It really takes, I would say, 5 minutes to get you set up on our website. And once you have done that, as I showed on the demo, setting up radios, even if you don't have an Active Directory, let's say it's a couple of hours of work, and you've got a demoable solution that you can go out and meet with your customers.
Great. That sounds great, Foster. Thank you. So the second question I had is, so for the user behavior analysis and the risk-based authentication to work, I think we are collecting a lot of information from the end users, machines, and their behaviors. So where is this data stored, and how secure is this?
So I think I answer this question. So if it comes to the mobile solution or behavior of your phone, that's a point that's very critical to many users because it captures so many aspects of your life. And
right.
Depending on the techniques, so this can be opted in and opted out on, well, it's in development right now, to be honest, on It's Me. You can choose whether you have this computation having on your phone. Of course, if you transmit the data to a server, you can capture more in that finer intervals because you have more computation power in the cloud than you have on your mobile phone. But on the other hand, you can opt in to have it locally on your phone only. That will also save a lot of bandwidth, but affect a little bit more your battery time. But we can guarantee that no information about you will leave your device if required to. So.
Right. That's very helpful to know.
If I may add, Stefan, we anonymize the information, so it's.
Oh yes, of course. Sorry.
Yeah.
Sounds great. So the next question. So how does Accepto leverage the context and user behavior analytics to balance risk and friction for our enterprise clients and their users?
Okay. Well, I spoke about friction earlier on and how some solutions force the user to either type a PIN or swipe their finger or show their face several times an hour, and that creates hostility from the users towards the solutions. In our case, what we do is once we establish context and we are tracking the user behavior, we can lower the barrier. For example, you authenticated successfully at 10 o'clock in the morning, you are in a safe environment, all the measurements show us that you are a very secure person. We won't ask you for your password until, let's say, lunchtime, because we are watching your behavior, we are not doing anything out of the ordinary. None of the characteristics that mark you as your identity, have changed. So why ask you to provide another password or to swipe a finger or present your face? And that's where, as I said, continuous cognitive authentication is essential. And that's what we use to introduce our user behavior analytics. It's not a mere, a table of distances. It's a set of attributes, as Stefan mentioned, that we use, and we keep track of them continuously to monitor the user and to make sure that his access is safe.
Right. Sounds great, Foster. And do you have any examples of having your solution implemented in let's say the healthcare vertical, where we do not want the doctors to kind of spend a lot of time entering the username and passwords, and they are on the move all the time. So how does
Yeah,
Accepto help in these cases?
we do have solutions where we use other values, such as, for example, wireless and Bluetooth, to monitor presence, and use that as part of the authentication equation. And we can always give more weight to an attribute versus the other, but it will always require, as I said, a multitude of attributes or factors in order to authenticate. But to answer your question, in the end, yes, we do have use cases in the healthcare.
Right. All right. That sounds great and very helpful. And Dr. Stephen, we talked a lot about artificial intelligence and machine learning, and although it came into picture a really long time ago, it's now becoming one of the uh, well-spoken or mostly researched subjects on. So what are the applications of AI, ML, and cybersecurity, and how does Accepto use AI, ML to reduce the friction of transactions while elevating the trust?
Okay, it's basically, it is the core of the whole system of the cognitive authentication. Well, basically, the word cognitive refers to the artificial intelligence in there. So we collect the data from various sources, and the machine, policies derived from machine learning in this whole artificial intelligence system, combined with rules that could be programmed by a human expert, will make the decision in cybersecurity whether to grant access to a certain resource or not, or increase the barrier, or in the end, ultimately, even perhaps lock you out of the system if there's strong evidence that this is an fraudulent or a malicious attempt.
Great. So we have time for one last question, and any quick thoughts from both of you. So I think you did mention, but if you could reiterate how machine learning is more advantageous than the manual policy-based or role-based authentication.
I didn't get completely the question. So your question was what are the advantages over machine learning versus the human manual-made policies. Okay, I had this on the slide. So the basic thing is, the most important thing is that, differences when a human creates a role, we do it with our common sense. So if you look at the example of, we're assuming that you're in England, but there's a login attempt with your username from China. It's a common sense that this is physically not possible unless you're Elon Musk and build a Hyperloop until there, and you got there in 30 minutes. So that's common sense. So you understand what a human defines, and you trust what a human defines. So that's the biggest advantage a human has. But the human, when he defines a role, these will be simple roles. It will be England at noon, China at 4 o'clock after in the evening. That cannot be. It will only have 2 factors in there, or perhaps a little more, but not too many. And in the end, you can fake those all. You can easily in a browser fingerprint fake that you're from the country where or you can at least attempt it. But you cannot cover all possible aspects. So we have much more factors that we can derive, or that we can cover about you. But that you cannot cover anymore by a human, because it's getting too complex. So the space of possibilities grows with the combinatorics. So it's exponentially growing, so fast growing that we cannot comprehend it as humans. But for the machine, that does make a problem. So they can define rules, which are working very well, but with the complexity also comes that we cannot really understand what the machine is doing. It's becoming a black box for us. So we know how the algorithms works, but we cannot interpret what's stored in there. So the mixture of both, combining the human together with the machine, gives us the ultimate trust in the system.
Sounds really great, Dr. Stephen. Thank you very much for that.
Thank you.
Right. I see a few attendees asking if the webinar is being recorded. To answer that, yes, we are recording the webinar and will share it with all the attendees within a day or two to your registered email addresses. And with that said, I want to take a moment and thank Fausto and Dr. Stefan for making this fantastic presentation and sharing great insights with us. And last but not the least, I want to thank each and every one of you who were able to attend today's webinar in the Citrix Ready Technical Webinar Series. And this shall conclude our broadcast for today. Thank you so much, everyone.
Thank you very much.
Bye-bye.